Question number 10th. The area of a equilateral triangle, the area of an equilateral triangle ABC over here is given to you with each vertex of the triangle as center. With ABC as centers, circles are drawn with radius equal to half the length of side of the triangle. So it's already given that the radius for each of these circles is half the side of triangle. If we know what the side of the triangle is, we can find out what the radius will be. Then you have to find out the area of the shaded region. Just like question number 7th, we are not considering the whole circles as such. We are only dealing with the area which is inside the triangle. So if from the area of triangle, we remove the area of the 3 sectors here, the unshaded portions here, these are the 3 sectors. From the area of triangle, if we take away the area of these 3 sectors, we will be left with this little area which is shaded in blue. That's what we want to find out. Now, area of the triangle हमारे पास directly है, हमें calculate करने की ज़रूरत नहीं है. But to find out the area of the sector, which is theta by 360 degrees into pi r square, we need the radius. So radius निकालने के लिए हमें side of the triangle चाहिए. So थोड़ा सा काम करना पड़ेगा हमें before we actually find the area of the shaded region. So the first thing you want to do is, with the help of the area of triangle given to you, आपको area given है as 17320.5. This is for equilateral triangle, and we know that area of equilateral triangle is given by √3/4 side square. Using this relation, you will find out the side of the equilateral triangle. From the side of the triangle, you can find out the radius for these circles, and then we can find out the area of the shaded region. And remember, the value for pi is 3.14 and the value of √3 is 1.73205, which will make your calculation easier here. Shall we
Yes,
start?
ma'am.
Right? Shall we start writing down? Okay.
Yes, ma'am.
So we have the vertices A, B, C for the triangle, and this area is shaded here. And let's write the answer. So using the value for √3, I've transposed the values to the right-hand side by side, converting decimal numbers to fractions. Simplifying, side is equal to square root of 40,000. So side comes out to be 200 centimeters.
Yes, ma'am.
And then what is given to us is that the radius of these circles is half the side of the equilateral triangle.
Therefore, R comes as 100 centimeter.
That's correct. So this will be 100 centimeters. Now you can find out the area of the shaded region. If you want, you can work in parts. You can first find out area of the 3 sectors, and then you can simplify. Area of shaded region will be equal to area of equilateral triangle minus area of 3 sectors. Since the sectors are of equal size, you can find the area for 1 and multiply it with 3. So theta equals to 60 degrees because it's an equilateral triangle. Each angle at the vertex will be 60 degrees. So this will be 3 times theta by 360 multiplied by pi r square. So you only need to solve this and then you can simplify.
One 15700 centimeter square, area of 3 sectors.
Complete answer?
Yes,
Yes,
ma'am.
All
and
right.
after subtracting it comes as 1620.5.
0.5 centimeter square.
Okay, this is the final answer.
Yes, ma'am.
Okay, so I will leave this to the
Yes, ma'am.
students. They can complete the calculation on their own, and it will be convenient if you just change this 3.14 into 100, then you can just simplify. Yeah. All right. I hope everyone will be able to do this. Anyone with questions here?
No, ma'am.
Let's take a look at the next question. Question number 11th. On a square handkerchief, 9 circular designs, each of radius 7 centimeters are made. So this is the figure given here. The radius for each of these circles inside is 7 centimeters. You have to find out the area of the remaining portion of the handkerchief, the one which is not covered by these circular designs. The one which is completely unshaded, you have to find out that area. So the area of the unshaded part will be equal to area of this whole handkerchief, which is square in shape, minus the area of these 9 circular designs. This is what we will do. Area required will be equal to area of square minus area of the 9 circles inside. To find out the area of the circles, we have the radius, that's fine. But to find out the area of the square, we need the side of the square, which is not given directly to us, but we can find out the side of the square. That's correct, Tarannum. The side of the square will be equal to the sum of the 3 diameters. So if we just show the diameters of each of the circles either horizontally or vertically, 3 consecutive circles hain. So this will be the diameter, this will be the diameter, this will be the diameter. So the sum of 3 diameters will be equal to the side of the square. And then you can work out your answer. Let's write the answer. You can either write down d plus d plus d, or you can write down 3d. So that will be 42 centimeters. Now you can find out the area of remaining portion of the handkerchief. So simplifying, if anyone has already done.
Yes, ma'am. Ma'am, area of
Yes,
square
ma'am.
comes as 1764 centimeter square and area of 9 circles as 1386. And answer as 378 centimeter square.
Anyone who's writing down?
No, ma'am.
Yes, ma'am.
Okay.
Done, ma'am.
After this 12, 13, 14 question I had discussed with you, I've even sent the answers for these. Question number 15th here, it's an important question. The figure given here contains a quadrant of the circle. ABC. ABC is the quadrant, so that means this angle here is 90 degrees. And the quadrant has been drawn with radius 14 centimeters. So AB and AC each are 14 centimeters. This is the quadrant, the portion which is in white. BC is drawn. BC would be the chord of the circle. BC is the chord. And if you take BC as the diameter and draw another circle, there is a half circle shown here. So there is a semicircle with BC as diameter. There are two things happening here. There is a quadrant for which the radius is 14 centimeters. उस quadrant में chord draw की गई है और उस chord को diameter लेकर semicircle draw किया गया है. You have to find out the area of this shaded region, the one in blue. So this will require a little work. Think of it carefully. How would you find out the area of this region? So normally, if you have to find out the area of shaded region, you're supposed to find out the area of the whole figure and subtract the area of the part which is unshaded. Use that. Just keep that in mind. Area of the total figure minus the area of the unshaded part. So if you look at the area of the whole figure, this whole figure is made up of two distinct parts. It will be area of triangle ABC and area of semicircle. Is that correct?
Yes, ma'am.
If I had to write this down, the whole figure as the area of two distinct parts, why I'm not taking a quadrant? If I take the quadrant, you will see that इसमें overlapped portion है. There is some portion of the quadrant which is common with the area of the semicircle. So I'm not using quadrant and semicircle. I'm using triangle and semicircle. Triangle will be this portion. If I just show you, this is the area of the triangle, the one shaded in orange. And then I can take the area of this semicircle. And then adding the area will give me the total area of this figure. From this total area, if I take away the area of the quadrant, now the quadrant is the one which is in white. Would you be left with the shaded area?
Yes, ma'am.
This is what we will do here. Now think of the values required to find out the area of these three regions. The triangle is a right triangle. So you need the base and the height. For the area of the triangle, you need the base and the height. We have the base and height. We can find out the area. For the area of quadrant, we require the radius. ये भी हमारे पास है. But for the semicircle, the one which has BC as the diameter, do we have the radius for this? जो ग्रीन वाला सेमी सर्कल है उसका रेडियस नहीं है हमारे पास. उसका रेडियस फाइंड करने के लिए आपको BC फाइंड करना पड़ेगा.
Ma'am, by Pythagoras in triangle ABC.
That's correct. Since we have a right triangle and BC is the hypotenuse of that right triangle, we will first apply Pythagoras to the triangle, find the hypotenuse, which is the diameter for the semicircle. From there, we can find out the radius for the semicircle. So multiple steps हैं इस question में. It looks like a very simple question. Figure को देख के लगता है शायद छोटा सा question है, but 3-4 marks में आता है ये, and it's important. So please do it very carefully. Let's write the answer. Please check if that's the answer. 14√2.
Yes, ma'am.
Yes, ma'am, यही है.
BC is the diameter of the semicircle. From there, you can find out the radius of the semicircle. I'm denoting the radius of the semicircle with capital R, just to distinguish. And then you can just solve your answer. Now, area of the shaded part. All right, let's find out the area of the shaded part. We first of all need to find out the area of the whole figure, and that will be given by area of triangle ABC. If you want, you can write down that we are taking the area of the whole figure, and from there we are going to subtract the area of the unshaded part. The area of the whole figure will be given by area of triangle plus the area of the semicircle. And then we will subtract the area of the quadrant, because the quadrant is the unshaded part. For the area of triangle, we will use the formula half base into height. For the area of the semicircle, half pi r square. And then for the area of quadrant, we will have 1/4 pi r square. Now for the quadrant, I have represented the radius as small r so that you can distinguish. Don't use the same variable. Radius is 14 centimeters, small r for the quadrant, and capital R is 7 times √2. So use the values carefully. The base and the height of the triangle are 14 each. The value of pi as such is not indicated, so we will be using it as 22/7. Then 7√2 squared minus 1/4 22/7 into 14 squared. Simplify. If anyone has already simplified and has the answer,
No, ma'am.
okay, then I'll give you a minute to solve it. This is 98. This will be 77 into 2, 154. 154. And then 22 into 196 over 4 into 7. $98,
Yes, ma'am.
right? This is 98 centimeters square. That gives you the answer for the unshaded part. Anyone with questions here? If you have any complicated figure, like in this case, always try to think of it. To find out the area of the shaded portion, you always want to find out the area of the total figure minus the area of the unshaded part. That usually helps. If anyone's writing, please let me know.
No, ma'am.
No, ma'am.
Last question, again, very important question. Question number 16. Calculate the area of the designed region in this figure, common between the two quadrants of the circles of radius 8 centimeters each. So the quadrants actually are indicated, and it looks like it's a square if we write this as A, B, C, D. So A, B, C, D becomes a square because all four sides are equal. You have to find out the area of this design region, the shaded portion over here, and this is included between two quadrants. The easiest way to find out the area for this is if you just draw one of the quadrants, and let's draw the diagonal for this, which will divide your square into two separate triangles. Okay, I think just if I had to find out the area of this shaded region here, which forms half the design, how would you find out the area of this shaded region?
Area of whole figure minus the area of triangle.
Yes. Can you tell me what's the shape of this shaded area? Which geometrical figure does this identify with? हमारे पास ये quadrant है, quadrant में ये chord है. Can you tell me what's this shaded figure? Yes, that's correct, Harshit. It's segment of the circle. हम क्या करेंगे to find out the area of this designed region? We are going to find out the area of the two segments here. So we will be doing it first for this portion and then multiply it with 2. आप सिर्फ एक सेगमेंट का एरिया निकाल सकते हो. ये जितना इस पोर्शन का एरिया होगा उतना ही एरिया इस पोर्शन का होगा. And if we look closely, if we draw one quadrant, then this acts as segment of the circle, and for this the area can be calculated as area of the quadrant minus the area of triangle. And you just need to double this area to find out the whole area. Tell me if the idea is clear, then we shall start writing. If it makes sense to you what we're doing here.
Yes, ma'am.
Okay. Because that's what's important to understand how we are calculating the area. After that, the application of formula is very easy. So let's write down. I'm naming my square as A, B, C, D. Just for convenience, I want to find out the area of this shaded region. So you can draw a diagonal here. Your figure is made up of two quadrants, so your area of the shaded region will be twice the area of segment formed in each quadrant. So 2 times. Now the formula for the area of segment, you are aware it's given by area of the sector, which is a quadrant here, minus the area of the triangle. So I will be taking the area of triangle BCD. You can take any of the right triangles formed at the opposite vertices. This sector is a quadrant here. You have the radii, you have theta. See if you require anything else. Since the triangle is right triangle, it will be half BC into DC. Simplify. Is pi given in particular? No. Simplify and tell me what the answer is.
One minute, ma'am.
Sure. Okay, Shreyas has calculated. It's 256 by 7. Let's check if I've obtained the same answer. Yeah, this is 256 by 7 centimeter square. And this completes your chapter number 12. Please start working on exemplar problems again before your exams. Work out the sample question papers given to you. Even if you've taken standard maths, please solve both. Like go for basic and standard as well. Whereas the ones who have opted basic mathematics, they can just work with basic mathematics sample paper. But solving the exemplar problems is necessary for each of you. Please work out, like धीरे धीरे करके एक एक चैप्टर करके सॉल्व करना शुरू कर दो. Always keep your syllabus like ready so that you can match कौन से questions कौन से topics deleted हैं. It will be convenient.